So this is like technically project 3, the daylighting project, okay? And so this week, what we're going to be talking about is data structures. And data structures are the reasons for some of the problems that we've been having is because we really haven't had a good talk about like data structures yet. Like the way that, because all that Grasshopper really does is basically like manipulate data, okay? It's taking from one list to another list, or it's making an operation on a list, or it's operating on like a group of things, okay? So we're gonna try to talk about what that is today. I'm gonna try to do my best. You may not need it for your thing, but it's absolutely vital for understanding like anything else complex that has to do with Grasshopper, because sometimes you just need to address objects like specifically in a very large group of objects, and this is how you do it. Where it becomes really useful, which may be useful to you, I found one thing is in creating structures for your buildings, like literally creating structures for things. If you want to create some kind of a space frame for your building, or like a truss or webbing or something like that, and you want to do it parametrically, data structures are a way to do that. So there's a very real like use for that. Again, anything that's really complicated with Grasshopper, you got to get into data. It's like a processing. You got to get into like arrays if you really want to handle a lot of things, right? You handle arrays in Grasshopper, right? You got to get into objects if you're doing things that are really complicated in processing. There's a similar structure in Grasshopper. So I'm going to do my best today to give you guys the groundwork for it, and then in lab we'll do a bunch of structural stuff. Like we'll make some trusses, we'll make some like decking, we'll make some joists and things like that, and I'll show you guys how to make those like parametrically. Okay, sound good? All right, so data structures. So let me know, this is, I don't know if I have, and it's okay for you guys, I don't think I have a full class's worth of content, so I'm gonna try to take it a little slower today. We'll still have videos, but just ask questions, and that'll kind of help things. So the first thing I wanna do is kind of start with the example that like Will asked about like a couple weeks ago. And that'll be a good thing to demonstrate like when we use things like Flatten and when we use things like Graft. Okay, we've done that a few times, but I've kind of like brushed it aside. I'm gonna try to talk about like what exactly that is. So I'm gonna start with a point, which is just an XYZ point, and we've seen this before, especially in Carson's section. If we give this some data, it's gonna make a point in space. Okay, you give it an X, a Y, and a Z coordinate, and it puts something together in space. Right now, everything's set to 0, 0, 0. But if I take a series component, which counts from 0, and it adds 1, and it does it like 10 times, so it's a loop, right? We've seen this before. If we add this in the X, we get 10 points, okay? I'm going to make extensive use today of panels, and this is something that really might help you guys out, because a panel is going to help us visualize like what's actually going on inside the structure. So you see I have 10 points that goes from 0, 0, and then 1, 2, 3, 4 in the X, okay? So that's what's actually going on inside that panel. Panels are just like ways of visualizing what's going on. They're almost like a print line statement when we did these things in processing. Okay, if you could get this, it's the same thing as you get if you mouse over, but of course the panel is easier to see and it's always visible. Okay, so that's one really nice use of panels for us. It also shows us like what the data structure is, and that's going to be helpful later. So panels are our friends today. Okay, so we show that, and then Will was asking, like, what if you wanted to make these into like a grid, okay? And if I just took a series and I plugged it in for Y, oops, actually Z, wrong axis. All right, Z. Yeah, we got like this kind of structure, right? And you can see if you look at the thing, what's going on is it's 1 in the X and then 1 in the Z, and then 2 in the X and then 2 in the Z, and you get like a stair step, okay? So that's because we've got the same data structure here. We just have 2 lists of numbers, and when they get piped in together, that gives you that point, right? And remember I said if you take one of these and you graft it, okay, then you get the grid structure that you think you want, right? You get that nesting. And this is just like nesting in processing, right? You would do like 1, 2, 3, 4, and then you add 1, and then you go again, and then you add 1, and that's how you get the grid. Okay, so it kind of like puts them into like a 10 pixel like container, And then we do that like in the Z like 10 times, okay? And if you look at the data structure, you can see that there's still 100 things, but they're in these groups that say like n equals 10. There's number 10. There's 10 things in each of those, and there's 10 of those, okay? And then if you go into the data structure in this panel, you can see what happens here. So there's the panel 1 has these in the 1, and it goes from 0 to 9. And then here's panel number 2, like container 2, has all these 2, and all these count up. Okay, so that's like what's going on inside of that like data structure. Okay, so I took all the ones that are in that X, and I actually did like a graft. Then that graft got moved in the Y, or got generated in the Y, let's say. Okay, and so that's actually the difference in this. This is how you get this grid. What's happened though is that I've actually, it looks like a grid, right? And so you would think that I could do some polygons. So I could take a bunch of polygons, and I need to change the axis of these. ZX, XZ. Yeah, got to do this first. Oh, and they're huge too. Okay, so I'm doing this manually. Okay, so got a bunch of polygons now. Okay, now I'm gonna do some kind of a transform on these, and let's say that I wanna randomly, you know, like rotate them. Okay. This is stuff we covered last couple of weeks. So take my polygons, put them in for the geometry, and random. Oh, and this is another thing too. We've done this before, but I really want to talk about this. So when we're doing arrays, we like frequently had to act on everything in the array. So we had this command, you know, in processing that was like array.length, right? And that would return the number of things in the array. Okay. In Grasshopper, there's a list length component, which does basically the same thing. If you plug that into something, it tells you how many things are in that. Okay, so that's a good way to know how many things you need. I think we've done this a couple times, but I've never really stopped to talk about it. So list length is a really useful thing, because again, if you did something that changed it parametrically, that would always tell you how many things there are, right? So you don't have to go back and change the slider. It just pipes that right back into your tool. Okay, so list length. So I could say like, okay, I got like 100 points, and it's actually showing me the length of that. But let's go ahead and do that anyway. So now I'm just going to generate a bunch of different values. And I'm going to pipe that in for, actually, let's see what's going on in there. What do we got there? Okay, so this is actually creating, yeah, this is going to do what I want it to do. Okay. So I've got my values, and I'm going to plug it in for, oh, and the planes are all here, and then the rotation. Let's turn these off. Okay. So that, if you look at it, should be kind of unusual. Do you see what's happening? These are all the same rotation. These are all the same rotation. These are all the same. It's kind of an optical illusion. Eh? Is there a way to like regen the randomness? What's that?
Is there a way to like regenerate the randomness?
Yeah, I'm not sure what you mean by that. Just change what the randomness is.
Well, you plug into the random, right?
Yeah.
But the random would the random be different every time?
The random, remember, is generated by a seed, and if I change what the seed is, like that's going to change the randomness. So if I plug in this for S for seed, yes. But do you notice again as I change it, it's not every one of these is turned like randomly, right? They're actually in these columns. Like the randomness is actually in columns. Okay, that's not what you would expect. Like you would think, okay, I made 100 things, right? I got this happy grid that I made, and I put random in here, right? And I plug in length, and these should all be different, but they're not. They're in these columns. Okay. So what happened was that when I created that graph to make that, right? I put them in those containers. Okay, and so if they're actually in these bundles, and they share the same structure. So when I use that structure to distribute my thing that says like rotate, you're going to get that. It's not going to return what you want. Okay. So this is kind of a bug that you might encounter because of the data structure that I created. This is why we have Flatten, okay? Because Flatten takes all those things and it basically blows them up again. So it's like, let's say I had a bunch of eggs, okay? And I had these egg cartons that have like 10, I have 10 eggs. I don't know why, but usually they're like a dozen, but I have 10 egg cartons, right? And they hold 10 eggs. And I have like a stack of those egg cartons, okay? And I can rotate each stack of those eggs, right? And that's gonna rotate them all. But what if I just took all the eggs out of all of those and I just put them into a thing, and then I can rotate them and they're all going to be like different, okay? Because I've taken them out of their egg containers, okay? That's kind of like what Flatten does. Does that make sense? Yeah. Okay. So if I flatten these things, because again, this is the data structure that I have. I don't know if I can flatten this. That's going to just do it. Yeah. So now you can see, look at this. Now there's no structure to it. It's just a big long list of these like things. And then if I go in, it just says 100. It doesn't have that funky like thing. So this is what I've been trying to get you guys to. This is what we've been doing all along. Is when I flatten something, it's like I want to obliterate any kind of structure there is, and I just want a list of all those things. Okay? Because then if I have a long list of things, I can just actually like address them individually. Okay, so this is like if you have like your louvers. If your louvers are all in one group, you know, when you make some rotation, they all rotate. But if you have them as one long list and you give them a list of different things, they all rotate like differently. Okay, so no, go ahead. Yeah,
Flatten basically gives you 100 separate points, like for the list.
Yeah, it gives you 100 separate points.
So they are not interconnected in any way.
Nope.
And Graft does connect.
Graft connects them. Flatten unconnects them. Great. That's a really good way to put it. Okay.
If you had duplicated them instead of the same ones that are moving up, if they moved across, would they be the same in each row?
Yes. That's a fantastic thought. Okay, yeah. Let's graphically demonstrate that. So the question was, if you distributed them differently, would they be in rows instead of in columns? So I would start by making them in the X. And then I would copy them in the Y, and then they would be in rows. And let's just do that really quick. So, and this is going to be, yeah. So turn that off, and let's do. I wonder if I flatten this. Oops, not flatten graft. Yeah, there you go. Okay. So depending on which thing I graft, maybe you want things in rows, you know. And you want to like rotate each one differently as you go. Like that's a way to structure that. Okay. I might come back to this later if we have time, and I'll show you how you could reorganize that structure yourself. Okay. If you get really, there's a whole thing in oh man, I lost my tabs. There's a whole thing in Grasshopper that lets you play with the tree structure of things. If you want to look in the documentation about it, where I can make any pattern I want within that. And if I started off in columns, I could remap the data so that it's in rows without changing what happens in the beginning of the code. You can do anything you want with the data structure. It just gets really kind of hairy. Okay. So yeah. So anyway, the point is, this is why we graph things, and what happens when we flatten things. Okay. So again, like now these are all, you know, basically random. And so again, these are all random numbers. This is our structure. And again, and this is another thing too, when two structures are similar, right, they're going to act on each other in a similar way. If you have a list of 100 things and you give it one rotation, all those 100 things are going to rotate the same way. If you have a list of 100 things and you give it 100 rotations, they're each going to rotate a different way, right? So you have to match those up. That's why the panels are really good for now. If you have trouble like visualizing that for yourself, okay. So when we do things like when we had to graph things together to make the loft, that's because we needed to make a common data structure for those things, right? Like with the stuff we did last week in some of the examples. So that's what's going on, okay. Okay. So in a really basic way, that is this kind of flatten and graft thing. Let's go on to talk about looking at the actual data structure of something here. So go ahead and start a new file, and yeah, let's see here. So in a really really basic way. I'm just gonna make a surface. And reference it here. Yeah, type this. Okay. So if we looked at this last time when we did like the brep components. So you can explode any object really, but you can take a surface and a brep explode is going to give you the faces of it, the edges of it, and the vertices of it. It's going to give you all the information that you need to like recreate it. Okay, so you can do stuff to it. And we've got this component. Actually, let me show you something else really quick. So, hang on, let me restart my Grasshopper here. I got a bug here. Huh, that is so weird. My tabs aren't working here. Yeah, I'm just gonna kill this and come back. Tabs are important. We want to see where things come from. Okay. What in the world? Maybe it's my mouse or something. No. Huh. Bizarre. Well, okay, we're just going to do it live. It's fine. All right. Okay. I'm gonna do the same thing, and I'll just tell you what tab it should be under, and I'll do it with the type in. Okay. That's all right. I'm not sure what the bug is, but gotta keep going. Okay. So brep components, which says explode. Okay. And what I can do is I can do a point list component. And this is really useful for when you want to, okay, so we've been working in things, I've shown you a lot of examples, but remember all these things come down to just like points and different kinds of geometry. And you can move points in the X, Y, Z, and then you can join them together with lines or make surfaces out of them. You can extract points from things and you can use them to like distribute geometry. You can extract points, use those to create lines, and then extract points from those. So you just have to think of these things in different ways. And sometimes if you want to draw on points in a different order, say to make trusses or like space frames or whatever, you got to know like what points you're talking to, right? Because there's just a big list of points, and how do you know which of these points is which, right? Well, there's actually like an array in here that stores all the points for every surface for everything, and but of course, like how do you know which points you're talking to? Well, there's this component. Let me pull it out again. That's like a point list, and it looks like 1, 2, 3, 4. And so that's actually what it does. If I take these vertices, these points, and I plug it in. Now you don't see anything yet because they're kind of tiny. Let me make this bigger. So there's the point list, and draw. Yeah, let's say these are fine. Then size. So plug this in. Okay, that's as clear as it can be. So the way that the geometry is actually, so there's a point 0, 1, 2, 3, and they actually go counterclockwise. That's actually how all geometry gets made on computers. It's just a rule. So if I wanted to draw like a diagonal brace, I might go from point 1 to point 3. I might go from point 2 to point 0, and those are actually different braces. If I wanted an X, I would just do both of those like together, and I would get like a cross brace. Okay. So let's actually do that. Let's extract that. This is your kind of like print line statement for points. Okay, this will work on anything. Like if I had like a chain, if I had a curve and I made a thing where I actually made it into like 10 points or 12 point divisions, it would say 0, 1, 2, 3, 4 all the way to like 10. And I would see which points those are so I could talk to them. Okay. Remember when we did arrays, and if you said like, okay, so you asked for something inside of an array, like I want that object at array index like 2 or at array index 10, and then you could pull that thing out. That's what we're going to do here. Okay. So I can go in. Only we don't have arrays, we have lists. So we say list item. Okay. And you give a list item an index, and you get what comes out. Okay. So let's pull a panel out. And let's see what we get with this. So the lists are these 4 points. This is really simple, but and the thing defaults to 0. And so if we're pulling out like list item 0, and actually if I mouse, yeah, if I pick that, you see the 0 turn green over there. Let's just, for the sake of visualization, which is always good, let's make this slider from 0 to 3. And if I plug it in, so, and then okay, hold this, so 1, okay, and you see the point, you see that I selected 1, 2, you can see that I chose 2 and 3, okay? So if you put a number in the item thing, you get that point out. That's how you can talk to certain pieces of geometry, okay? Now, so we can do that. We can let's get rid of that, and just for now, this is a little bit. This isn't the way that I would do it, but I've got point 3 and point 1, and if I make a line, so your lines just take a point A and a point B, you get that point. Okay. So that would be a very simple piece of a structure. Now, when I do this, typically I don't use sliders. I actually just extract the. Well, actually, let's do something else here. So if I did 2, 0, I would get that line. So it's actually parametric right now. But what I do is I extract these. So I would go through and extract them. And then I actually change the name of it to what I want, like 0. That doesn't actually do anything. That's a label, okay? Then I go and I set integer to 0. And I do the same thing here. So extract parameter, make this 2, and I set integer to 2. So that way I have like a little like price tag that tells me like what's actually going on in that thing. But it's not parametric because I'm not interested in changing it. I want it to always like be that. That's the convention that I use, and you'll see that a lot. That's how I learned it, and you'll see it on the Grasshopper forums and stuff like that. Okay, so again, just making and how would this be relevant? Well, if you can't use your imagination, I'll show you. So I'm gonna make a pipe component and make it a very small radius. Oh wait, actually that's too small. So let's do 0.5. So I got that. So I have a pipe. Then you can take the edges from the original BREP and pipe them in. Hide this stuff. And that's the beginnings of a frame for something, right? Or the beginnings of a truss for something. Okay, so this is where we're going. Okay. Remember, we do this parametrically, so if we have this pattern, we can distribute it over something. So in fact, why don't we go ahead and do that? So I've got a surface. Okay. So I can go in and disconnect this. References. There we go. Okay, and actually hit it. So, and then I'm gonna do our old standby to divide it and ISO trim it. Oh, shoot. Okay, there we go. And so we divide it into a bunch of things. Okay. So so I've got that. And what I can do is I can pipe that into the explode. And now it's going to show all those points. I don't want to do that. But see, once you get that structure figured out, these need to be smaller though. Let's put a number slider in there for piping these things. There we go. Okay, where's my surface? Okay. Oops. I'll do that. No. Broken. Yeah, okay. Hide that and then preview that. Okay. That's what I want. Okay, so if I use that logic over that surface, right? Again, I have a list of surfaces that are part of that. I took that one surface, I broke it down into 100 surfaces. If I pipe that structure in, see each one of these has 4 points, but they're in these little like egg cartons, right? These item things, when I ask for index 0, it returns the first point in each of those like surfaces. So the data structure allows me to talk to each of these things and get that point, and then draw that line, and then pipe that stuff, and I get my space frame kind of surface, right? We could do even better than that, okay? So I can take, remember I showed you guys that you could do a different like direction. I can go in and I can set up some of these to be in the other direction. So make these 1 to 3, let's say. Yeah, that works. Okay, so these are 1 to 3, and then let's go ahead and put some of these in here. And again, well, so here right away, I mean, I could actually get it if I did them in both directions. I could get like an X, right? Because I'm just crossing them. I've got both of those, okay? But why don't we do something more selective, and let's do like a dispatch, and let's send some of them to be one way and some of them to be the other way, right? We could do that. So let's just take a dispatch component, right? Which pipes things into 2 lists based on some kind of true-false thing. And right now it's just set up to be true-false. It's going to alternate. So I can take my list of surfaces here, and so just to show you what's going on here. So half of them, these strips are A, right, because it's every other one, and then the other strips will be B. So I take my dispatch, remember, because it's just true-false. I'll clean this up in a second here. Okay, so what I'm gonna do is I'm gonna take this list. Whoa, I gotta start to take this list A, plug it in for this. This is really messy. Okay, let's move these over here. And these are going to be mine in one direction. Just move that. The pipe stuff is going to go over here. And if I take another explode and use these vertices here and here. Okay, is going to. Oh, I didn't plug it in. Ah. Okay, so do that. I need to get the. Need to take this out too. So where's my Take E to E, or E to pipe. Yeah, and that's going to be that. So once I've got that dispatch thing, I could go in and drop a panel, plug it in for the true false, and say true, false, false, true, multi-line data. And that's going to give me, I could do more complicated patterns. Okay. One trick that I did, I won't show you for time, but I used to do a thing where I took the curvature of this, because you can test each curve for its curvature, whether it's curving in or whether it's curving down or whether it's curving up. And I piped like half the list to grids that are going one way and half the list to grids that are going the other way, and you actually get a roughly structural like diagram, because the moments of force are where the ones coming in are coming up, and the truss members will actually die into each other in the right place. So anything you can do that generates a true-false test can be piped in for the dispatch, right? And that can give you the direction of these things. So you can do like you could do every third one is going to flip, or you could do all kinds of patterns for this. But kind of like that actually. If you got the numbering right, I mean they kind of start to form like X's and things. Like it's pretty interesting. So
So what you were just describing, because my question right before that was, if those struts basically, if they curve, do they really function the same way as they should in a truss system?
They really aren't intelligent like that, but they look pretty intelligent. That's a really good thing. Now, again, though, there are if you could figure out what the forces are in some other program, you could certainly pipe it in, and it could select whether or not those things meet together. we're going to do a thing on Thursday where I do a little bit of like an intelligent truss, where no matter what size truss it is, the chords will meet in the middle. So there'll be chords going this way and then chords going that way, so they always resolve in the middle. You could do a thing where they resolve as a V in the middle. You just put some logic into it, right? So you would like divide the list into half and say, okay, the first half of you guys are right-handed and the last half of you guys are left-handed. You can do that. This is so, you start to destabilize how you think about these things. I mean, you think about them logically, there's lots of things you can do. And even if they're not maybe structural, they're pretty darn close. And once you have this, you can put this onto any surface that you make, right? So that saves you a lot of time drawing this stuff. Your professors don't care if it's like perfectly structural, it just has a structure, So these are the kinds of things that can kind of help you out. They're kind of like a modeling aid, Well,
how do you go about making it so that you can individually control every single box? Would it be like a flatten?
To control each box?
Yeah.
Yeah, you'd flatten it, but then you could talk to it using a list item. And you could give you could put a series into a list item, and you could get like every 1, 2, 4, 6, 10, 11, pull those out and do something to them. Okay, you can use that list item thing as a way of pulling out more than one thing. But right now I'm pulling out the same number thing in every one of those 8 cartons. Okay, yeah. We'll see this in a second, like how that actually works. But this is just an idea of saying like you've got like. We're drawing these because we can talk to certain points. We can talk to point 1 and point 3, and we can draw a line between them. Okay, and this stuff becomes more and more useful as things go on. But this is a basic kind of grid pattern. Okay, one more thing I want to show you guys. Make sure I got this right. Yeah. Okay. So another demo that I like to show. Let's do this in perspective. So I'm going to start with a circle. And I'm going to move a copy of it. Need to make this bigger. And let's make these, make these bigger as well. Okay, so I got some pretty meaty circles. Okay, then I want to scale the other circle. So let's take this and do area. This is all stuff we've seen before. Okay, and scale the other one. So do that. Okay, clean this up a bit. Okay, so I've got my 2 circles here. And what I'm going to do is I'm going to divide a curve to this geometry. I'm going to make a copy of it and divide my original circle. So I got like 2 lists of points, right? And I've got list of points here, like 10 points, right? It's a flattened, list. And I have a list of points here, okay? And if I take lines, I can connect these to these, and I get like a basic kind of. So anytime, this is a really cheap kind of way to do things like this. You can take any 2 lines. You can take a straight line and like a curved line, and you could create a bridge by like connecting those points. In this case, I'm creating kind of like a Toyo Ito kind of basically some kind of like a tubular structure. But this isn't what I wanted to show you. This is just the beginning. So if I take a slider and I can make it natural numbers, real numbers, plug it in for the, now it's important that these have the same number of points, right? Because otherwise the computer is going to try to like match one list to the other list. And if you don't have enough, it just takes the last one and just kind of dumps all the other ones into it. So that's actually what you're seeing here. Okay. If I show you something, will you not do it? You guys may have noticed that if you right click on these, there's this kind of shortest list, longest list, and then cross-reference, okay? That actually details the data matching behavior of the thing. And so longest list attempts to make the longest list of these, so it's gonna dump all those into that last point. If I do shortest list, it's gonna stop when it runs out of data to match, okay? Like it doesn't, there's more points on the top than the bottom, so it runs out, okay? And don't do this. If you cross-reference it, it just takes everything and references it to everything else. This will crash your computer in most cases, like because it's just going to attempt to like match everything. It's like it's like everything cubed, you know. It's like this point's going to go to all 100 points, and then that point's going to go to all 100 points, and it's going to do that until it runs out of data. Okay. Sometimes in a very limited capacity that's useful. Most of the time it's not. So by default, everything is on longest list. That's what that is. If you ever wanted to know, that's the data matching behavior. Okay. The reason I'm showing it though is because it's important to have these lists have the same number of points because then the data like matches. Okay, right? The thing that's an array 0 on the bottom curve matches array 0 on the top curve. Array 1, you know, matches on both. Array 2 and so forth. Okay. So it's really important to do that. Now you've got the panel. I'm gonna drop a couple panels here. Or I'm gonna drop a panel. So you can see I've actually got a list of all those points in space, okay? Of the top, or the bottom, sorry. Let's just do this one. Of the bottom chord, yeah, top chord. Okay, and what I'm gonna do is I can shift, so I can pull something out of a list with an index. I can shift a list. So what I can do is I can take that list and I can move all those values over by like some amount, okay? And that can be really useful to us. So if I take this list and I pipe it in to here, it's like playing the lottery here. Do you guys see, like I've actually popped this one out. And now what was 1 is 0, and what was 2 is 1. So you can see that I've actually like shifted that list over. I've manipulated that data. You wish it was this easy in processing, right? Like if you could manipulate data like this, I do. You can take a slider though, and let's increase my screen here. Peek this, so you can shift it. And okay, so when you do it though, you see it runs out. Like when it's shifted, it actually just, it pops all those things out and they don't come back. If you change this behavior to wrap values, so change it to a true, it's actually going to go around and it's going to replace those. So it's like you took all the eggs out and then you put them in a different order again. Okay, I don't know why you did that, but that's what happens. Okay, so you can see I've shifted it like 17. So what was it, 17? This like -7 is now up at the top of the list at 0. Okay, what does that actually get you? Like, why is that like halfway interesting? I will show you. So if I take the shifted list, let me disconnect this. Take the shifted list and plug it in, and it twisted. Because instead of connecting 1 to 1, 1 is going to like 17, 2 is going to 18, right? And so on and so forth. And you can get all kinds of stuff. Okay.
What is it actually doing at where it curves in? Like what's the line actually doing?
It's because they're going so far across each other, it's tightening up. Like they're shifting so much that's creating, like if you go back to no shift, so 1, what's that?
Can you just loft it so that we can see what the surface is doing there?
Can I loft it? Okay. Well, let me show you something first, and then I'll do that. Okay, so just to kind of do a kind of a cheap, like Toyo Ito truss, not that any of his buildings are cheap at all, but okay, so I've shifted them by 1. Now watch this. And if I get this right, yeah. So if I pipe that, I've got a tubular like truss, right? Do you guys see that? Like, So I've just shifted it by 1. So it's kind of like when I said point 0 talk to point 3, right? But I've got two sets of lines. I've got one set of lines that are the ones I shifted, and then one set of lines that are the ones going up and down. And when I take those all together and pipe them, I get like a tubular truss. Okay. You could certainly take a collection of circles and move them and randomly change the sizes of them, and then do this logic to that. You get one of those trusses that's in like the MediaTek. Okay. Parametrically. And then you can make like 10 of them. You know, and they all are different. So this kind of logic is really, you know, shifting lists is really useful. Now, to Yashka's question, can I loft it? Short answer, yes. Long answer, it might be difficult. Let's take a look and let's see if this actually, yeah. So it's not joining the last pieces of it. So maybe I can close it. Ah, okay. That was easier than I thought. All right. Yeah. Okay. I thought I would have to do some data crunching here. Cool. Kind of like a maypole. All right, turn that off. Yeah. So you get some kind of like paraboloid kind of structure through the like twisting of it. Shift works really well with loft. This is what I thought I would have to do. So lofting, you take one curve and another curve and it like lofts across it. Okay. If you wanted to loft a more complicated shape, you might take a list of curves that's like these, and then you shift a list, and then you loft them together, and you'd get a collection of surfaces instead of one surface. Does that make sense? So like I have all the curves except the last curve, and then all the curves except the first curve. And since they have the same number of curves, if I loft those together, that's going to create separate curves. It's in the example that I gave you guys. Week 3, part 3, when I did surfaces that use the power curve, I actually used that logic in there. Okay, so you can follow through with that. So shift works really well for doing these kinds of operations here. That's one example. Okay, let me do another one here. Actually, doing better than I thought I would. Okay. Let me show you something else. Actually, I'm just gonna do this easy way. Okay, so I've got like a long, skinny surface. I'm gonna reference it as a surface. And I'm gonna divide it. But I'm gonna, yeah, well, we'll do this in a second here. Subsurface. Okay, so I've got this. What I want to do though is I only want one division in the U. I only want one in the V. Okay. We'll fix it. Okay. It's probably too many, but okay. That's what I want. So if you look at this, I've got like this. Okay. So I'm gonna talk about some kind of like web truss logic, basically. So if you have some kind of truss that hangs onto your decking, usually the top chord's long and like the bottom chord's like smaller, right? You have these kind of angled pieces that come in on that. Okay. We can make that we can make that like parametrically. Okay. Using the same kind of logic. This is going to be like a review of a lot of the things that we've done. So I've got these surfaces, and I've got a list of 6 surfaces. Okay. And what I want to do is I want the first one to be going, down at an angle, and I want the other one to be going like up at an angle. Okay, so I want to do something to the first bay of this and something to the last bay. Okay, so how do I extract something from a list of things? What's the component? List item. Yes, thank you, Chanel. 2 points for Gryffindor. Okay. Which list item do I want to extract from this thing? I have a list of 6. Which one's the first one? In an array, what's the first item? 0. Yes, awesome. You guys are computational thinkers. That is 0, because by default, list item is set to 0. Okay? How would I get the last item in the array? List length? Yeah, that's a good start. Okay. Very good. List length. 2 points for Gryffindor. Or, I don't know, Ravenclaw? What are we? I'm not sure whose houses everyone's in. We need the sorting hat. Okay. If I plug in that, oh, what happened though? What do we think happened? Yeah, but why is it broken?
Because it's saying there's 6 items and there's no 6.
There's no 6th item. Why?
Because it's 0.
We started at 0. So how do we turn that into the number we want?
Can you do an expression?
Expression. Yeah. Very good. So what's the expression? Very good, guys. Yeah, I'm -1. Excellent. There you go. Okay, so first thing, last thing. Okay. So now we can go in and we can explode those brep components. And we'll do that one. Okay. And so we've got that. Now, how do we find which point is which? Because we're still kind of newbies with this thing. Like, how do we know which one of these numbers is which? Point list. Very good. So plug in the vertices in the list, and let's just set the size to be. What can I not do there? Oh, okay. So yeah. Okay. So it's actually the same as it was. So what do we want to make that? If we want this thing to kind of go like this, what do we want? Excellent. Okay, 3 to 1. Good. So let's just take a list item, make 2 of them, and I'm going to simplify things here. Yeah, 3. I think of the order I want. Yeah, 3 to 1 is fine. 3 to 1. Okay. Oops. I plugged it in the wrong thing. Coffee. Okay. Line. So you got that one. Okay. Then we do the other one. Same deal. Only we do from 2 to 0. And you know, this isn't like a big deal, but it's something. Okay. And then what we can do is we could, let's see here. We could also do a thing where we take these surfaces and we could call, this is where call inth comes in, or call index. So item extracts something, right, from an index. Call index would remove something out of an index. So we can get a new list that just has certain things we want, okay? So we could actually take these subsurfaces, and if we call 0, we're going to just get only those things, okay? And then if we take this list, and we call the length, so we take the length of the new list, and we call, oh, actually that seemed to actually work for some reason. How about that? Oh, let's kill that. Okay, so I minus 1. Wait a minute. Too many things going on here. Okay. Oh, I got the wrong, I get the list. Yeah. Yeah, okay. So what I did was I took that first list, I removed the first item, and then I removed the last item. And so now I've got a new list. So we've got call, we haven't seen this yet, but we can actually call things from an index to make the list we want. Okay, so I can call those things. Then I can take those into brep components and then just get the edges I want. So that's how I get those middle chords I want, okay? And then let's just put in the ubiquitous pipe. You could do this with lots of different things, but and then you could always go through and check this out. So I can make a line with any 2 points, right? Let's go ahead and hide all these. That's not what I wanted to do. Okay. So if I wanted to make the top chord, and maybe I wanted to take a cross section and do like a loft along that, or sorry, like a sweep along that, I could find. Let's turn these on here. I could find the item. My points aren't showing up anymore. I could find the top one and plug it into a line. Oh, there we go. Now they're coming back. Okay, so we've got this point, and I've also chosen this point, so I could make a line across those, because I've actually pulled those points out from something, right? And then I could find a line for the bottom one. So I could find this one and this one, and that's going to give me the bottom line. Let's go ahead and hide these. Okay, and then so I've got here, I could use these to get the edges of that. I can get the line from the top, I can get the line from the bottom. So I could give them each a different, I could give them each like a different radius, so that the top one's thicker, the bottom one's thinner, and the inside pieces of the truss are a lot thinner. And that would give you some logic to it, okay? So being able to talk to points, being able to cut lists up and like talk to certain parts of lists, or how you can get these things to be the way that you want them to be. And you know, again, this is parametric. So if I gave it a different like surface, if I gave it a different range of sliders like that, that's gonna preserve the logic in this piece, like this kind of web, okay? And if I had more time, if I wanted to show you something really complicated, you could do a thing where you can take your building, cut it into sections, use those lines to make surfaces, and then pipe surfaces into this, and you would do all the decking in your building, like parametrically. Okay. Once you get this logic down for one component, right? It's just about finding. It's like, how do you find a surface, right? You could do that. So we'll do more of this stuff on Thursday, but again, once you get this logic down, it's a power tool, right? This is like having like a really powerful, just kind of like factory for making this stuff for you guys. And then you can experiment with the spacing of your decking or the number of chords in it or something, and then really quickly put that in your model, okay? As opposed to doing it all. Or if you have like a really curvy surface, it would make all the bracing for you automatically, right? If you move this vertically, this could be what holds up your curtain wall, okay? You could go in and put cross bracing in X's or something like that, like wires. You could do that. Just make them really small pipes. So this structural logic is really useful. Okay, we got time for one more. So I want to show you, and this might get a little confusing, but I hope not, what you can do when you manipulate list logic in more complicated ways. Okay, so I've got two things, and what I'm kind of thinking about for this is sort of like I just saw this like on Architizer, if you guys have that on Facebook or if you visit that website. But there's this airport, and you see this structure up here. So there's like a curved line and there's a straight line, and so you can join those. But then in between these things, there's this kind of like zigzag kind of pattern. So like two points are going to one point. Do you guys see that? Okay, so like, how would you get like those points to talk to that one point, right? And do that in like a parametric way. This is actually a thing you can model like parametrically, right? Especially after today. So that's kind of the idea that I had last night when I saw that. So as kind of a demo. So I'm going to divide both of my curves by the same by the same domain. So I've got two sets of points. And what I want to do is I want to have like these points like go to that point, and these points go to that point, and these points go to that point. So I want that kind of logic, and I want it to be parametric. Okay. And hopefully this is going to work. So what I'm going to do is I'm going to take a list item, and I'm going to extract. So I've got, if I do my list, my point list, it's going to be helpful. Yeah, so I've got a list from 0 to 10, okay? And so I might say like, I want 0, 2, 2, 4, 4, 6, 6, 8. That's the kind of pattern I want. I want to like repeat that thing in my list, okay? So I'm going to take this top, take this piece right here, and what I can do is I can do a series. And in my series, what I can do is I can say that it's going to start at 0, and it's going to increase by 2. And it's going to be, let's say, whatever. Oh, I don't even have a slider for that. Okay, let's make a slider for that. So let's say 30, some round number. And we'll set it for 10 for now. Because we need to know how many are in here, and we need to control those parametrically. So these are always going to be the same. And then let's say that this is going to be whatever this is divided by 2. So C divided by 2. And I get a series of numbers. I'm going to get 0, 2, 4, 8. Let's do 0 divided by 2 plus 1. Yeah, okay. And if I plug in my list and I plug in my index, you can see that I actually get, so it's kind of like a cull pattern. But so you can see I don't have to just talk, I don't just have to take a list item and get one thing, okay? I can take this whole kind of range of things, and I can get that. Okay, so I've got this list of points, but this isn't actually like the pattern that I want. Let's do something similar, and I'll show you why this doesn't work. So if I'll take this list, and I'm going to do a new series, plug it in, and this one I want to do like 1, 3, 5. Okay, so I'm going to go in. This is going to start at 1, and I'm going to add, let's see, 1, 3, 5. Yeah, and then this one I'm going to take off the +1. Wait a minute, I plugged in the wrong list again. Let's fix this. Okay. These are down here. These are up here. Okay, so I got these, and I got these. And you would assume that you're done, right? But if you plug those two lists in, like it's not the kind of logic that you want. Because again, it's going to match whatever 0 is in the index to 1 in the index to 2 in the, it's just going to try to match up the indices to each other, okay? What you want are like two things in an A container, right? A container 0 to talk to list item 0. And then A container 1 talks to list item 1, okay? Does that make sense? So we need to do something with series to actually structure it. We need to structure the data. So I'm going to put a series into a series, okay? Like exhibit, right? No, you guys don't know that joke. Okay. I put a car in your car so you can drive your car while you're driving your car. Okay. Yeah. Okay. So I'm going to put a series into a series, and so the series is actually 0, 2, because that's the first two things, and then I'm going to make a pattern of that. Okay. So my first series is going to be really simple. It's going to be set number 0, and then set increment to be 2, and I'm going to do this for like 2 values. Yeah, it's going to be really dumb. It's 0, 2. Okay. Then if I take this, and I'm going to start with. Disconnect that. I don't need an equation or anything. Okay. Yeah. Wait. 2. That's all I want. It's 2. Okay, 0, 2. And then I've got these. So I want 0, 2, and then I want 2, 4. So I'm going to take whatever that is, and I'm going to add 2 to it 5 times. Okay, and that's going to give me that structure. So I got 0, 2, and I'm going to add 2. Starts at 0. So I'm going to plug in my starting numbers. Yeah, so it's not quite right. 0, 2, plug it in times 2. So this might be. Yeah, okay, so let's look at the structure. And so it's actually created a list, so I've actually grouped these together, and then that's what's going to create that pattern for me. So by taking a pattern of like 2 numbers and then putting that into the series, right? If you plug a list into something, it's going to do it like multiple times. So it's like I took that 0, 2, and then it's like 2, 2, 4, and then 4, 6, and I had those patterns. And then if I plug the first list into it, it's going to try to connect things to the number of things it has. It's going to create that pattern. And if I go in, and I don't know if I just discovered this recently, but you can take a slider and you can right click it and you can make it so that it's always even numbers, and that's always gonna give us a nice distribution. So I can even numbers. Let's turn these numbers. Oh, we don't need these anymore. If you did that with 2 like arcs, okay, instead of straight lines, you got that. And then if you took those points and you didn't do all this like list manipulation and you connected them to a line in space that was here, you would get that kind of structure. And in fact, I have like a minute, so I'm going to go ahead and do that. You guys mind? All right, you're stuck anyway. Okay, so what I'm going to do is I haven't shown you guys this before, but you can take. Just going to turn all this off here. You can take a line, and you can turn it into a curve using a NURBS curve. So I take a curve that I draw. Oh, you know what? No, this makes it even cooler. Hide this. Okay, so I can take a point and an x, y, z. This is going to be a better lesson. Okay. So I've got a point. Let's say it's 0, 0, 0. Okay, and I'm gonna take that point and I'm gonna move it in the x. X. And number slider. And big, so 50. Okay, so I can take these 2. There. Okay, so I've got that, and then by doing that, I can make a line, right? So now I've got a parametric line, okay. And if I can take that line, and I can look, I can evaluate the length of it. Yeah, let's do that. Yeah, point on curve. And this is a slider box that if you take this, it will give you a point at that distance on the line. So if it's 0.5, it's halfway on that line. Okay, it's like halfway distance. So that's the midpoint of that line. If I change that slider to 0.25, it's a quarter of the way. So it's a nice little handy like widget. So this is called point on curve. And then I'm gonna move that point in the z. And by some equally obscene amount. And then I get like this kind of structure. So I've got a point that goes like that, and I've got my endpoints, okay? And the whole thing is, fully parametric. Okay, still with me? Okay, so take a curve, and this is a NURBS curve, and so you take 3 points, and it's going to try to create an arc over those things. So I have 3 points, so the curve degree has to be 1 less than that. So it's just a curve degree 2. The first point is my point. The second point is the point that I have moved in the middle. And the third point is the point that I moved. So I've got a curve. Parametric. Okay. Now check this out. You guys are all going to become bridge designers. Okay, so we've got this, and I'm gonna move that curve in the y by some distance, and that is going to create the other side of my bridge. Okay, and in fact, I could go ahead and do something pretty similar with my line that I made here, and that would give me the other side of that piece. Okay, so then I can go in and I can divide the curves by some number, and I can do things like connecting these together to create, that piece of it. Okay, and then I can take my my curve. So instead of, this is going to get confusing here. So this is the one that this is my top one that I made. And this is my first one that I made. Cross your fingers. Okay. Yeah. Okay. So again, this is what we saw, and it's totally parametric. I can go through and I could adjust, now this doesn't match up with it, but I could make it match. I think you guys can figure that out. The dimensions of this are parametric. The width of it is parametric. Where's my other one? The distance that these things are between each other is parametric. So that kind of logic. So if this was your design, you could actually study this design. You could play with that bottom chord, the placement of it. You could play with the spacing of it, the arc. Okay, but you still had this logic of this kind of zigzag. Again, if you got these to sync up, you would get that logic of it. Okay, I hope that was somewhat interesting. So this is going to be posted online pretty soon. If you guys have questions, I'll be around for a few minutes. Thanks for your patience and thanks for your attention. You guys were good today.